everyone, it's us again, and today we want to tell you about the difference between correlation and causation.
Now, you might have heard that there's a link between energy drinks and diabetes,
Spicy food and longevity.
that there's also a link between Hong Kong's divorce rate and death by typhoons.
Or maybe even between milk tea consumption and the average grade of a student.
But what does the word link even mean?
Well, scientists, when they're talking about things that are related, they prefer to use words like correlation and causation.
So then, what's the difference between them? Let's take a closer look and find that out.
So causation is a cause and effect relationship. In other words, you have an event or a situation and a reason why that happened. For example, if I drop this pen, it will fall. So gravity causes the pen to fall. This is causation.
And correlation is an entirely different relationship in which two different variables are related to each other, but one does not cause the other. A good way to decide if there's a correlation between two variables is to graph your data. For example, let's say you want to know if there's a relationship between the number of hours a student studies and their GPA. You can survey 25 students about both these variables and graph your data. You might get a graph that looks like this.
Notice that, in general, as the number of hours spent studying increases, so does the GPA. You could say that there is a correlation between these two variables. Now, there are many different types of correlations. There are positive correlations, negative correlations, and some correlations are stronger than others. So what does that look like?
In a positive correlation, as the variable on the x-axis increases, so does the variable on the y-axis. They both increase, resulting in a line that looks like this. In a negative correlation, as the variable on the x-axis increases, the variable on the y-axis decreases, resulting in a line that looks like this. As we mentioned, correlations can also be strong or weak. In a strong correlation, all the data points will be very close to one increasing or decreasing line. In a weak correlation, the data points might be scattered around a bit, but still follow a general upwards or downwards trend. If you have a graph like this with data points scattered all over the place and no clear trend, these two variables are not correlated.
Actually, you can look for correlations between any two variables in the world, and you might be surprised by what you find.
Like what?
Well, let's take a look at an example.
Let's look at some data on the number of people who died by becoming tangled in their bed sheets and the amount of cheese consumed between 2000 and 2009. These lines closely follow each other, meaning that there is a correlation, but you know that consuming cheese does not cause people to get tangled in their bed sheets, so there's clearly not causation between these variables. Many people make the mistake of assuming that correlation automatically implies causation. But we certainly shouldn't advise Park & Shop or Welcome to start selling less cheese to prevent people from getting tangled in their bedsheets and dying. It would be ridiculous to make a policy decision based on this data.
But we see people confusing correlation and causation in the news every day. For example, many food-related studies lure you into believing that eating spicy food causes you to live a long life.
After scientists found that the people who ate spicy food more often tended to live longer, several major publications covered this incredible link between chili peppers and longevity.
Turns out that the fountain of youth is in a bottle of sriracha. But even the scientists who ran the study felt that they might have stumbled onto a correlation, not a causation.
See, the study was conducted in China, where spicy food is often a status symbol. It is likely that the people who eat spicy food also have more money and better access to healthcare than the people who eat bland meals. And in that case, it's likely the money and not the spicy food that causes the long life. So as you can see, if two variables are correlated, one might cause the other, but there's probably more factors involved, so we can't make that assumption without further research.
Now, that doesn't mean that there aren't any correlations that also have a causation. For example, there is both a correlation and causation between cigarettes and lung cancer, sugar and diabetes, DSC grades, and getting into a good university.
Or paying attention to this video and understanding the difference between correlation and causation.